Hi, in this lesson I want to talk about how we can use fossils to date rocks. So we're bringing together the two parts of this particular topic. Fossils are an immensely useful dating tool. For example, the ammonite on this image found at Lyme Regis is indicative of rocks from the lower Jurassic. But for a fossil to be used to date rocks, it needs to have a number of key properties. And it's those properties that I want to discuss in this video. You'll need to make your own notes from this video. There isn't a handout to go with it. Okay, let's go. Let's start by thinking about what we're actually talking about when we use this term zone fossil. So a zone is a period of time during which a particular faunal assemblage or collection of fossils actually existed. So a zone is if you like, a unit of time. And we name this zone after a characteristic species of fossil that's found within that zone. Something that defines it. And that is the zone fossil. We use them to help us establish relative timescales and to be able to link together a sequence of rocks in one place with a similar sequence elsewhere based on this fossil content, and particularly of the key zone fossils. Okay. To be a zone fossil, there are some characteristics that a fossil must have. Let's go through each of these and think about why it is. We need these fossils to be geographically widespread. Now, the reason for that is we want to be able to correlate rocks in different places. So, for example, if we look at the limestones of Carboniferous age that we find in places like Ogmore by Sea on the South Wales coastline, if we find the same fossil, the same coral fossil, in limestones on the west coast of Ireland, in County Sligo, for example, we can establish that those two rocks were deposited at the same time because they're geographically widespread enough to be deposited in places that are hundreds of kilometres apart, maybe even thousands of kilometres apart. The best type of organism for this are animals that live freely swimming in the sea that can tolerate a wide range of conditions. Remember, a zone fossil is all about the time it lived, not the environment it lived in. These are the ones that are likely to spread furthest and spread fastest. And related to this, we describe a good zone fossil as being facies free. So it doesn't just live in one very particular environment. It can live in lots of different environments at the same time. Ideally, to be a good zone fossil, the species only lives for a short time before that species becomes extinct. So it evolves rapidly and becomes extinct rapidly. The shorter the time period that this species is around for, the better defined the boundaries of that zone are. The result of that is it's in a limited thickness of beds. We only find it in a small number of beds at a particular point in time. So the result of this is we see a rapid evolution of an organism through lots of short-lived and crucially easily recognisable evolutionary stages. The diagrams at the bottom here show the evolution of the cephalopods. As we go through geological time, a key feature of these cephalopods, what we call the suture line, changes. More about that in another video. Another key feature is that a zone fossil should be abundant. If we think about Tyrannosaurus rex, very recognisable, iconic fossil, I suppose. It fulfills some of the requirements to be a good zone fossil. It only lived for a short period of time, right at the end of the Cretaceous period, but we don't use it as a zone fossil. It wasn't geographically widespread; it's confined to North America, and perhaps most importantly, it's really not very abundant at all. It's quite a rare fossil. So we need these organisms to occur in vast numbers, so it increases our chance of finding them where we need to find them. Now, to be a good zone fossil, it also needs to make a good fossil. It should preserve well. It needs hard parts. We need a fossil to easily preserve, so we can find it in the rocks that we're looking for it. Now, there's quite a lot of criteria there. There are different groups of fossils that have different degrees of usefulness as zone fossils. That might be at different times in the geological column, or it may just be some of these organisms are far better suited than others for the job of dating rocks. What we need to do next is to try and evaluate which ones may be useful to us. So, as we see the sunset at Lyme Regis, a good zone fossil has a number of key characteristics. Now, as geologists, we have to deal with the data that we have. We can't create data that doesn't exist. So, the fossils that we use may not have every one of those characteristics, but they must have a good number of them, otherwise we're really not going to be able to use them. They must have the short lifespan. There is a brachiopod called Lingula, for example, that evolved in the Cambrian and is the same today. So if you find Lingula in the rocks, it tells you very, very little about their age. If you've got another species that only existed maybe for a few million years in the Jurassic, finding that pins down the age far more accurately. And they need to be good fossils. What we need to do next is really dig into how the different groups of fossils may actually be useful to us and try and evaluate those. But that's for another lesson. I'll see you then.